Hello. In the fourth and final step in this activity, where we're creating a console-based volume of a cylinder calculator, we are going to account for two things. The first thing we're going to account for is the problem in that when the user enters a string for radius or height, the program crashes. We don't want that to happen. It's inevitable. Your program's going to crash from time to time, and you're never going to be able to account for everything, but we can use this structure called a try-except structure to try and account for some situations where the program crashes. The second thing we're going to do is we're going to take every calculation and store it in a file so that when the program's done, the user can then look at that file and look at all the data they've done. So with that in mind, what I've done is I've set up a new file, convol style step 4, and I've copied everything from step 3 into here. So let's just run through the error that we're going to run into here. So if I run this, I can put my name Paul, and if I put the name monkey for radius here, and I hit enter, it crashes. It crashes specifically because of line 17, where it's trying to cast, remember casting is a process of changing type, the radius value, which is monkey, into an integer, and it can't do that. It's called a value error. So what we can do here is we can use something called a try-catch structure. And how that works is as follows. Come down here. The way it works is as follows. I write the word try around some code block, and this is the try code block, and I can have as much code as I want here. And again, this would be tabbed in. So anything tabbed in would be inside the try code block. And then what I have is an except structure. And this is the except code block. So what happens is that at any point in this try code block, I run into a runtime error. For example, trying to cast a string to an integer. It's going to stop and jump down to this except code and then run that code. And that stops the program from crashing altogether. So if I look, the two lines that can cause me this problem is this line here and this line here. The problem that I'm talking about specifically is trying to cast a string into an integer. And if the string isn't a number, that's a problem. So I'm going to say try, and I'm going to highlight these 4 lines of code, and I'm going to tap them in. So basically now is if this fails or doesn't work properly, it's going to stop and jump down to here. And so what I want to do, I want to print, and we want to make this look nice, so I'll use the escape code again, numeric type required. So essentially what's happened now is that if I enter a word for radius, this is going to fail and it's going to jump down to here. So let's save this. Let's give it a try. So if I put the word monkey here, I get numeric type required, which is exactly what I want. Oh, and how many of you saw that I put a slash instead of a backslash for my escape codes? There we go. But notice it still crashed. And the reason it still crashed is because I told the program to continue on, and then it hits this line here, and it tries to check is monkey greater than or equal to 0, which is a problem. So what I'm going to do in the except is I'm actually going to force values for height and radius. So I'm going to say height is equal to -1 and radius is equal to -1. So what this does now is basically if I enter something for radius or height that's invalid, it's going to jump down here and set these to a values that is going to cause this if statement to jump down. So let's watch that in action. Let's clear this. Paul, and I put monkey. I get numeric type required, and then you have entered an invalid value. And that's because when I enter the word monkey in line 18, it tries to cast monkey to an int, which is a problem, and so that fails, and it jumps down to this except structure, prints out numeric type required, and then resets height and radius to -1. And so when the code continues, this if statement evaluates to false, and it jumps down to the else. And that causes my program to no longer crash. This try-except structure, sometimes called try-catch in other languages, is really useful. And we're really just scratching the surface. But it's a nice way of ensuring that your program doesn't crash if the user inputs strings where numeric types are expected. Okay, The second thing I want to do is I want to store information in a file to be accessed later. So to do this, what I need to do is I need to declare a variable that's going to point to a file. So if I say I'm going to make a variable called file, and I'm going to use a built-in function called open, and I'm going to put a text file name here. So if this text file exists, it's going to access it, and if it doesn't exist, it's going to create it. If you look here on the left-hand side, you can see data.txt exists because I've done this before. But just for the sake of this, I'm going to take this file and I'm going to delete it. And the second parameter I give the function is what I want to do to it. So there's a couple options here. I could write, I could read, and then there's an option for read-write, which I suggest you avoid. The other one is append, which is quite useful as well. So if I come here, what we want to do is we want to write to this, meaning that anytime I access file, I'm going to write whatever string into that file. So let's come down now and think about where do we want to write the results. Well, we only want to write the results to the file if this is true. So I'm going to come into my if statement. So if the height and the radius are valid, I'm going to say file.write, meaning write something to the file. And I'm going to write the volume, but I have to cast it to a string. And I'm going to put a \n because that's going to introduce a new line in the file. The last thing I need to do with files is I need to close them. So at the very end of the program, the last thing I'm going to do is I'm going to say file.close. If I don't actually close the file, the data won't get written to it. So I'm going to save this. Let's go run this. So now if I put my name Paul, and you see already that data.text has been created. Let's do that again. Let's come over here. Let me delete this, delete file. Let's exit. Okay, so watch right here. So ready? When I run it, the file gets created. So my name is Paul. I'm going to put 2, 3. I'm going to put 7, 8. I'm going to put 4, 5. And then I'm going to say 0, 0. So now let's come over to data.txt and let's look inside. There are my values. And this is a great way of keeping data after the program is completed. Now, the last thing I'm going to do in this, I'm not going to get into reading from files in this video, but I'm going to talk about append. If I run the program again, what it's going to do, 9800, what it does, you'll notice, is it wipes out the file that existed before. It clears the content and just kind of starts fresh. But sometimes I want to continually build to my file. So I can put an A here, and that means append. So if we come back here, we see data has some values in it. Let's save this. Let's clear, and let's run this again. If I put 5, 6, 4, 5, 0, 0, and let's take a look in here. Notice the old values are still there. So depending on what you want to do, you can either write, meaning start fresh, or you can append to a file. It might be interesting here to put an option at the start of this program to ask the user what they want to do. I hope this video helped, and if you have any questions, please don't hesitate to ask. Have a great day.